Okay, so my name is Nick Jansma, and the topic today is measuring the performance of single-page apps. So slides are available in SlideShare right now if you want to follow along. I tweeted them out as well from my Nick J Twitter. So SlideShare/Nick Jansma. So I'm Nick. I work at SOSTA. SOSTA is a web performance analytics company. We also do cloud testing. And I'll get into a lot of that in a little bit, but first I want to talk about why does performance matter, right? So the title of the talk is measuring the performance of single-page apps, but why do you care about measuring performance? So I don't know about you guys, but whenever I go to a website that's slow, I get angry, right? You get frustrated. You're frustrated you can't use the site like it's meant to be. Slow sites mean angry visitors, and angry visitors mean lost customers, and lost customers means lost profit. There's a study out recently that for a site that earns $100,000 a day, just a 1-second slowdown means you could lose $2.5 million in annual sales. That's a lot of money. This is actually pretty relevant today. I was looking at the Twitters this morning, and people were talking about Ryanair. Ryanair actually recently redid their website in Angular. And while it looks fantastic, a lot of people were noticing how slow it takes to load. So this guy was finding that it takes 30 seconds to load the homepage. And there's all sorts of people that were complaining about it. I actually went and loaded it from here on my laptop. It took 59 seconds for me to see anything on the Ryanair website. This is from Web Page Test, which objectively measures web page performance from different locations around the world. And up until 42 seconds, there was only white essentially on the screen. The site was not usable. So I bet you they're losing some customers. Well, it looks fantastic once it's loaded. Because it's a slow site, I bet you they're losing customers and they're losing money. So measuring your performance is step one to understanding it. Until you understand it, you can't have things like a performance budget. You can't measure yourself against what you want to be. And if you're not measuring it, it's going to get worse over time. I'm sure somebody's coined that law somewhere, but if you're not measuring it, it's getting worse, guaranteed. So before we jump into measuring single-page apps, I kind of wanted to go over some definitions just so we're all on the same page about things. So the company I work for, SOSTA, we are a real user monitoring company, RUM, not the type, Captain Morgan type, but real user monitoring. Real user monitoring is about measuring the page load performance of your visitors in the wild, so your actual visitors' page load experience. The opposite would be something like synthetic monitoring. So synthetic monitoring is sending bots or controlled, emulated users to your website in a controlled environment. And with synthetic monitoring, you can get very stable results over time, but it's not what your actual users are seeing. So we measure RUM, we measure the real-world page experience via JavaScript. There's all these great events, there's all this great data that the browser can provide for you to measure how your users the experience your users are getting in the wild. So we can listen for things like the ready state changes or the loaded event in the DOM. Or the onload event. The onload event is when all the static content on your page has been fetched, so all your JavaScript and your CSS, stuff like that. The browser, from JavaScript, you can measure things like the DNS time, the TCP time, all the really core networking components of your page for your like root HTML and stuff. From something called navigation timing, and I'll go over that in a little bit. And other user metrics, if you're using something like user timing, which is a way of marking important events within the lifecycle of your app. Real user monitoring, JavaScript can measure that and bring it back. Real user monitoring also gathers characteristics of the page load, like what browser it is, what the resolution is, where they are in the world, what connection they're on. And you can take all this data and beacon it back to your servers for analytics, right? So you can do big data analytics on what all of your users in aggregate are seeing all over the world. So one of the things I talked about was navigation timing. Navigation timing is a recent browser API. Have you guys heard of it at all? Anyone? Like 1, 2 people? Yeah. It's a great, fantastic performance interface that's available, I think, in about 82% of the market share today. Navigation timing is available as window.performance.timing. And there's all these different timestamps that you can get. So the millisecond resolution, from the beginning of the page load process, you can get how long it took for DNS and TCP, the core content of your page, so the core HTML, and then all the DOM events, so like even the DOM content loaded, DOM complete, and even the onload event. And all these are exposed as timestamps that you can access from anywhere within the page. Yeah, so navigation timing is available in most browsers today. Safari 9 was the holdout for the longest time, so we didn't have good stats on mobile, but finally with iOS 9, we actually have navigation timing in iOS. And so it's a really great interface to be able to actually gather these real-world performance metrics from your users. Something related to navigation timing is called resource timing. So where navigation timing measures the core HTML page load experience, resource timing tracks all of the resources on your page, so all of your JavaScript, your CSS, et cetera. And it gives you a lot of the same timestamps. So everything from the DNS and TCP times, the core content times, and how long it took to respond. And the inspiration for this was like browser waterfalls, right? So in like Chrome Developer Tools or IDev Tools, whatever, you have this waterfall of all the resources on your page and how long it took to load all of them. And this waterfall really gives you an indicator of how long it took your page to load, because the longest tail here will be the longest resource that took to load, and will be only once all of the resources have been fetched is your page visually complete, and the user thinks that they can interact with your site. So the great thing about resource timing is you can actually get all this data in the wild. For every single one of your users, you can capture this waterfall and analyze it later if you want. Resource timing isn't available as nav timing. It's only available in about 56% of the global market share. The big holdouts are Safari, both desktop and Mac or iOS. But hopefully that'll change soon. And so we've been talking about RUM, and one of the project that I work on specifically at SOSTA is Boomerang. Boomerang's an open source project. It was created a couple years ago by Philip Tellis, one of my coworkers when he was at Yahoo. Boomerang gathers all the things I was just talking about. So for every single page load in the wild, Boomerang will gather the navigation timing, the resource timing, all the important characteristics of the page, package it up, and beacon it to whatever server you want. So send that payload to your backend analytics server if you want. It is an open source project. We at SOSTA contribute to it a bunch, but there's a bunch of other people that are contributing to it as well. So you can use it for free. You can actually use this project to gather the data and send it back to your own analytics engine. But today we're talking about single-page apps, right? So I'm sure if you guys have heard of single-page apps. Who's building a single-page app right now? Majority of you. Single-page apps are becoming more and more popular. Gmail, for example, is like one of the first single-page apps. Frameworks like Angular and Ember, Backbone, React, they're becoming a lot more popular for building websites. And single-page apps actually cause a lot of problems when you're trying to measure the performance of your page. Clearly, the Ryanair people weren't measuring the performance of their single-page apps. Or actually, I did find that they were, but they must not be looking at the data, because I saw them using a pingdom, and they're clearly not looking at the data. But in the single-page app world, there's two very important distinctions when you're, for example, loading the page load performance of a single-page app. So there's a hard navigation, and then there's a soft navigation. So hard navigation, a hard single-page app navigation is the very first page load, the very first time a user is coming to your site. This is when the browser has to fetch all the core JavaScript and CSS, HTML. It has to fetch the core framework. So if you're using Angular, it has to fetch Angular.js. And Angular itself, or whatever framework you're using, has to render the view that you're on. So whether you're going to the home page or to a product page, the framework has to figure out what view to show you, fetch that template or however it's figuring out what to show you, inject that into the DOM, maybe there's images, and all that stuff has to be fetched together. That's a hard navigation. It's a really expensive navigation, right? The very first time is very expensive. Everything after that's a soft navigation. So when you're going from like your home page to maybe a product page on your site or back and forth, those are soft navs. The browser isn't refetching the same JavaScript and HTML. It's only fetching the difference, the dynamic content that it needs to swap in to go to the different view. And an important thing is, for most frameworks, any URL on your site can either be a hard or soft navigation. So if you have a product page, if you're a retail website, and a customer is going from your home page, which it did a hard navigation, to the product page, that would be a soft navigation to it. But if they're coming from Google, for example, directly to that product page, you could actually come in as a hard navigation. And the reason why this is so important is because the performance characteristics are so vastly different between the two. There's all this extra work that the hard navigation has to do that the soft navigation doesn't. So if you're looking at this type of data, you really have to bucket your navigations into two different types. Instead of just being a page load, it's either a hard or a soft page load. So there's three major challenges to measuring single-page apps. The first thing is that the onload event no longer matters. So the onload event, again, is when all the static content on the page has been fetched, and all the JavaScript and CSS. The browser fires this onload event. This is traditionally what RUM tools have hooked into to measure the page load experience, because the page isn't complete until all the resources haven't been fetched, right? Well, so here's an example from my blog, nickj.net. These are all the resources that have been fetched. I got images and some CSS and some JavaScript. The page load fires at the very end here, after the very, very last resource is fetched. And that's great, because this is when the page is visually complete. This is when the visitor feels like they can use it. But for single-page apps, I'm going to show you that the onload event really doesn't matter. Like we said before, all the static content on the page is fetched, so like the JavaScript and CSS and Angular itself. But that's when the onload event fires. But then after that, the framework actually starts. It's actually like, oh, hey, I'm here. What view am I going to render, right? And it decides what view it needs. It maybe fetches some extra templates for that, puts that into the browser. And the browser needs to then go fetch all those resources. And all that happens after the onload event. So here's the Angular example app from the GitHub webpage. To the left, this is the onload, the line in the middle. Everything to the left of it's static content on the page. So JavaScript, jQuery, CSS. Angular itself is right here. And that's actually what triggers the onload event. The latest thing to be downloaded was Angular, because it's probably so big. But what's all this stuff over here? Well, this is the actual content for the page. This is actually what the user is going to see. This is some core template for the example app. I think it's a list of like phones and their images. And then all these images, basically, for all the phones coming after that. The onload event fired at 1.2 seconds, but everything wasn't downloaded until 2.5 seconds, nearly double the time. Here's a film strip view of the same waterfall we were looking at. So this was captured via web page test, which takes screenshots every 100 milliseconds or so. And remember, the onload event fired at about 1.2 seconds. At 1.6 seconds, we don't actually see anything on the page. It's blank. I mean, there's a little bit of crap up there, but it's not until 1.7 and 1.9 seconds that actually stuff starts visually being complete on the page, and the user would actually, would use this page. There's nothing there to use, right? So if you're paying attention to the onload event in a single-page app, you're really not paying attention to the right thing. And unfortunately, that's what most RUM tools today are looking at. That's what most people in the real world are tracking as the page load event. If you're using Google Analytics, for example, site speed, that's when they would call your page load complete. So yeah, so the core problem is that most of the interesting stuff that's loaded on a page in a single-page app loads after the onload event. And the browser doesn't fire any more events after that. It doesn't fire a fully loaded event. So we're going to look into some solutions around that in a bit. But the second problem, the second challenge at least, is that soft navigations are not real navigations. So every time you're in a single-page app, you're clicking on something, going from page to page, that content is dynamically fetched. The browser isn't navigating in real terms to that other page. The browser isn't unloading the old page to load the new page. The frameworks can actually change the URL that you see in the address bar so it looks to the visitor like the URL is changing, like they navigated. But in reality, they're just swapping content in dynamically. And this is great for performance, right? You don't have to refetch the same JavaScript, CSS. You don't have to execute it, reparse it. You don't have to re-render the same header and footer all the time. But it's bad for people that care about performance because traditionally, after the onload, RUM tools wouldn't care about anything after that. The most important thing is getting the content to your visitor. And after the first time they do that, RUM tools would expect the browser to re-navigate the next time a page load happens. And all the browser events, so like ready state and the onload event, they only fire once for each stage. And navigation timing, all those timestamps I showed you, they're only geared towards one single navigation. So you won't get these other in-page soft navigations. So that's the second challenge. The third challenge is that the browser won't tell you when all these other resources have been downloaded. The onload event only fires once. It helps us know when all the static content on the page is fetched. In the soft navigation scenario, the browser won't ever fire it again. So we don't actually know when all the rest of the resources have been fetched. Remember, this is the waterfall we showed before for Angular. This is when onload fires. There's nothing that fires over here. We don't know when all these resources have been fetched. But all those resources are important. Those are like the templates or the JavaScript or CSS, images, videos, XHRs. All of the content that contributes to the core visual completion of the page. Now, some of the frameworks actually fire some interesting events around when you would think some of the content is being rendered. For example, Angular fires a route change start when you're changing the view, and it fires view content loaded, which sounds fantastical. But this isn't actually when the view is visually complete. It's actually just when the template for the next view has been loaded. That template may contain external resources like external images or other JavaScript that needs to be fetched, and all that will contribute towards the visual completion of the page. So yeah, in this Angular scenario, user clicks on something, Angular decides what view to show and fires the route change start, fetches maybe a template via XHR, renders it, maybe there's some images that go into it, hands it off to the DOM, and this is okay, view content's loaded, I'm all set, I'm all done. The browser knows what to do next. But this is not when the browser is done with everything. But now the browser has to go and look at everything, say, hey, there's a new image I have to fetch. There's new JavaScript that needs to be fetched, and I need to execute it. And all of that will contribute to the visual completion of the page. Here's when the view content loaded fires. It's just after fetching this little JSON. But this is all the visual content that we wanted to show on the page. So those are the 3 challenges for measuring single-page apps. They're not like a traditional website, right? And we really want to measure page load performance. It's very important for measuring what your user experience is. So for any performance monitoring scenario, you'll need to know the start and end time of something, right? That's the duration that you're interested in. So how are we going to measure single-page apps? Well, what's the starting event, right? What can we measure from? For a hard navigation, it's the same thing as a traditional website. It's when the user initiated an action to load your web page. So it's when the user clicked on a link or opened an email, opened from an email to your website or clicked on a bookmark or typed in the URL bar. This is the same time as like a traditional web page. So you can use things like navigation start, which is the timestamp for when the navigation started, which is great. So we can key off that. And even if navigation timing isn't available, if you're navigating between pages on the same site, you can use things like cookies to keep track of when the user last initiated an action to go to the next page. But remember, soft navigations aren't real navigations. So we know how to track the beginning of a hard navigation, but how do you track the beginning of a soft navigation? We need to figure out when the user is initiating an action to look at a new view. Now, there's a couple things we can key off. The window history events, which fire every time the URL is changed. You can listen to those. Some of the frameworks, like we saw, Angular has a route change start event that you can listen to. Or you can listen to other interesting things, like a click or maybe an XHR. Some of those sometimes trigger additional activity. And if you're not using a framework like Angular, you may want to listen to some of these things. So the window.history object can tell you when the URL is changing, when the user is visiting a new page. There's these push state and pop state APIs that you can listen to that basically means when the URL is changing. And when the user is clicking forward or backward, these events will fire. And you can use that as the beginning of what you're measuring. As I said before, there's frameworks. They have their own events for when things are going to happen. Angular has route change start. Ember has before model and will transition. Backbone has the route event. React's router has a similar event as well. But that's not the entire story. You can also just listen for interesting clicks on the page. Now, not every click's interesting, right? The user could just be scrolling or clicking on checkbox or something like that. But you can listen to see what happens after the click, to see if the DOM significantly changes, to see if the core content of the page significantly changes. And so you can start listening with a click or an XHR and see what happens after it. Now, an XHR, XML HTTP request, they're really used in single-page apps to fetch the core content of the page, right? The core templates or data that you're going to be displaying. And if an XHR is happening and when it returns, it changes the visual view of the page, you can use the beginning of the XHR as the beginning of the soft navigation. So we have all these interesting start events, like something's happening. Now let's measure to the end of it, right? What is the end of that? Well, what do we consider the end event in a traditional page load? It's the onload event. That's when all the static content on the page is loaded. There's a couple different definitions of complete for a page load. When all networking activity is completed is the onload event. Some people say the page load is complete when it's visually complete, above the fold complete, so when all the content in the viewport is complete. Some people say the page is complete when the user can interact with the page. And these are all valid things, and it depends on what you're tracking. But what we're going to do is we're going to build an event that's very similar to the traditional onload event for single-page apps. So we want to fire when all the when all the regular resources on the page have been fetched. because the page isn't ready until at least then. And it's usually when the user can fully interact with the page. Now, why do we do this? Why do we wait for all these resources? Well, they all contribute to the visual completion of the page. So every JavaScript file, every CSS has the opportunity to mess with the page, to change its content. Media, images, video especially, they're going to change the visual of the page. So we want to wait until all of them are complete. And if any of them fail, they're single points of failure. They're going to make the page not complete. They're going to make it not visually complete. So we want to make sure we can monitor all these. Now, for hard navigations, remember, the onload event doesn't matter. The onload event only measures up to when all the static resources have been loaded, which is the framework itself, but not the actual view. So for a hard navigation, we want to say the end event is when all of the additional content has been loaded, right? So all the view content has been loaded. And for soft navigations, it's a very similar thing. The browser doesn't tell us an onload event for a soft nav at all. Now, I talked about resource timing a little bit before, where we can get the end times of all these resources that are on the page. The problem with resource timing is it doesn't tell you about the network activity until it's completed. So you don't know if there's any outstanding resources on the page, things that are still being fetched from the network. And if you don't know that, you don't know whether you can mark the end of an event. You don't know whether you can mark the end of that navigation. If you don't know there's nothing outstanding, you don't know when to end it. So you basically have to monitor all network activity on the page. So we're going to make our own onload event for single-page apps, for hard and soft apps. It's going to be similar to the body's onload event. We're going to wait for all networking activity to complete. And this means we have to intercept both implicit resource fetches. So this is things like when you're putting an image into the DOM via template or something, the browser is going to go fetch that data, as well as programmatic fetches, like from an XHR. You can create an XHR object and go fetch data. We need to monitor all of it. So how do we do that? Well, first of all, let's start with monitoring XHRs. Excuse me. So XHRs are important, right? Because they fetch the HTML, templates, JSON, additional data for the user. And we really wanted to know if there's any XHRs outstanding on the network. The good thing is the XHR object itself can be proxied. You can overwrite it if you want to. You could screw up your own web page. But what I mean by proxied is you can actually intercept it, intercept all calls to it, and know when an XHR is being started and when it's completed, because you can listen to all these events. So I'm going to show you a little bit of code. It's really simplified over what the actual code is needed to do all this. If you want to get it later, take a look at the Boomerang repo and this plugin, Auto XHR plugin. But I'll give you just kind of the core idea. So the first thing is just save off the original window to XHR object so you can call it later. Overwrite it with your own function. Then we're going to overwrite two methods. Open. Open is what people call to set the URL for the XHR that's going to start. And as soon as they do that, we're going to start listening for all the important events. So load, timeout, error, and abort. And then we're going to call the original one. We're actually going to call the real XHR object at that point. The second function to overwrite is the send function on the XHR. Here you would save your start time, so just a timestamp. And then you'd actually just pass it through. And what this simple code does is it actually gives you two things. You're monitoring the timestamps for the beginning and end of all these XHRs. And most importantly, you know if there's any XHR outstanding. You know if there's a fetch that hasn't been completed yet. Yeah, I just said all that slide. But with that code, you can monitor all the important things that you need to about an XHR. There's a couple downsides to monitoring XHRs that way. The timing isn't as accurate. If the browser is really busy, if the browser is doing a lot of CPU work, your timestamps may be delayed because the callbacks will be delayed. You could fix up those timestamps via resource timing if it's available, but you shouldn't necessarily use this to just do performance tracing on your XHRs because it can be affected by other browser activity. But with this, we at least get to know if there's any outstanding network activity via XHRs. So that's great, right? We've intercepted one of these things. But what about everything else on the page that can trigger a download, an image or CSS or script? Now, you could actually proxy the image object in a similar way, where you could hook into new image and make sure everybody that's calling new image, you're getting those URLs. But who in here builds their entire website via JavaScript and new image? Yeah, nobody. So we don't want to do that, right? That's just not practical. What if we could listen for DOM changes? So the great thing is there's this thing called Mutation Observer. Mutation Observer is a very performant interface. When you start listening, you get notified of all the changes to the DOM, so all the core HTML that's being changed on the page you get notified about. And you get callbacks whenever new things get inserted into the DOM. I'm going to show you a little bit more sample code again, but feel free to look at the real actual code. This is creating a Mutation Observer. We're just listening on the document. And we're saying, hey, Mutation Observer, tell us whenever any changes in the HTML of the page happen, especially if there's a source or href associated with them. And then Mutation Observer will call back, fire a callback whenever the HTML is changed on the page. This code isn't really as interesting, but we're basically looking at all of the content, all the DOM nodes that have been inserted, and we're looking for interesting things to pay attention to. So when we get notified, for example, of an image or a link attribute or an iframe that gets inserted into the page, we can actually insert ourselves in there, hook onload events to all of them, and we know that the images are being fetched from the network. So we know that there's an outstanding image that we need to wait on. And then, once all these resources have been fetched, wait a couple more milliseconds just to make sure that there's no additional activity kicked off from like a new JavaScript or something like that. And if not, the navigation is complete. We've created our own onload event for single-page apps. Not all DOM elements are interesting. Not all images are interesting. For example, you can have an image with a data array, and that's not going to go to the network. That's when you're hard coding the image into the page. Scripts, inline scripts that don't have a source tag, they're not going to go to the network, so you shouldn't wait for them. And you only want to look at link elements that have the href for CSS and stuff like that. Mutation Observer is available in 83% of the market share today, which is great. So most of these apply to most of the browsers that we're talking about. The big downside here is older versions of IE don't support it. There are some polyfills available for IE, meaning you can actually put these JavaScript on your page and you'll get basically the same interface, but there's some pretty severe performance implications. So if you want to do any of this, definitely consider your users first and whether or not it's worth the performance overhead of monitoring things these ways before using a polyfill like that. So we've talked about the page load experience, right? How long it's taking to get to the core visual content of your page. But that's not everything. What about widgets? What about ads? What about other components on your page? The good thing is you can apply a lot of the same techniques that we just talked about to page load components. For measuring anything, you need a start time and an end time. Start time is probably when you start to construct your widget or your ad, when you're injecting it to the DOM. The end time, you can measure via the same thing. You can start measuring for the same components on the page, and you can fire your mini onload event for all these widgets or ads. But how do you measure the visual completion? One really important thing to know about, when you're adding images to the DOM or when you're adding other HTML to it, when you put it when you give it to the browser, that's not immediately when it becomes available. The browser still has to do, parsing, layout, rendering. It'll take a while for the browser to go through all this content and show it on the page. And so if you really want to measure visual completion of your components, you need to kind of take that take that into account. One trick is to use a set timeout of 0 or a set immediate. What I mean by this is after you've done your important work and you want to measure how long it took the browser to pay attention to the work that you just did, do a set timeout of 0. In the case that the browser needs to do work, in the case that it's going to be a very expensive operation to parse all the HTML that you gave to it, the browser won't call you back until it's done. So even though it's a set timeout of 0 milliseconds from now, it might take 100, 200, 300 milliseconds. And then that's when the content is visually on the page. It's not a perfect solution. The browser may do some things asynchronously on another thread. But it's much better than putting your head in the sand and ignoring the fact that there's all this other activity that the browser needs to do to actually display the content you're trying. And so that's all great, right? But what about what happens to your app over time? What about the life cycle? It's not just about measuring specific interactions. It's about measuring how good of a citizen you are, not only for your app, but for your customers. Tracking metrics over time can highlight performance, reliability, and other resource issues. And in Boomerang, the script that we work on for real user measuring, we measure a lot of these different things, and you can measure them over time. So you can measure memory usage, for example, in browsers that support it. Chrome specifically right now, but there's this window.performance.memory object. And you can see how much memory usage you are using, and you can actually see if you're having leaks. You can measure just even simple things like the size of the HTML in the DOM, which can be a good indicator if it keeps on growing, there's some sort of leak going on, and you're leaking memory for your users' computers. Same thing for DOM nodes. JavaScript errors, very important to track over time. You can use something like Track.js if you want, which is a service that collects these errors and reports on them in real time. You can measure how many bytes you're fetching over time. All that content on the network can be important for your visitors, especially visitors in other countries that maybe have a metered connection. And finally, you can use things like request animation frame to get the frame rate to make sure that when people are scrolling on your site, it's not janky, it's not shaky and stuff like that. So, I talked about a lot of things. They probably sounded a little hacky. We had to jump through some hoops to build a lot of these things. It'd be really nice if the browser just kind of gave us these events for free, right? So can we measure this kind of stuff in a more performant way, in a way that we don't have to hook into Mutation Observer and hook into every XHR? The good thing is that the W3C, which is the standards body, is working on something new called the fetch standard, and it gives you a fetch observer. And the key thing here is that it notifies you when a new resource is about to be fetched. So instead of us having to hook into XHRs and using Mutation Observer just to know if there's something outstanding on the network, we can actually just listen via this, and it's way more performant. So I'm hoping that gets added to browsers soon. So that's what I got for today. The other thing I will say is my company is hiring, specifically my team, for Boomerang. So if you're interested in any of this stuff at all, we need really good people to help work on problems like this. But I'm happy to take questions, and thanks for listening.
So with the information between hard and soft timings and single-page apps versus apps that have their assets cached in the browser way, is there a good answer of single-page versus not with that type of performance data? So
you're asking whether you should be bucketing the data differently, like looking at different segments of the data based on whether it's cached or whether it's a single-page app, hard or soft? Or something else?
More apples-to-apples comparison of apps that are not single-page and their performance timings versus single-page apps with the performance timings?
Yeah, so I would argue that the way that we're measuring single-page app, like hard navigations, for example, it's very, very similar to what you would measure from a traditional website. In fact, we had to build all those tools to measure beyond the onload event to actually capture the core content of the page, right? It's not until visual completion of the page that the user really feels like they can interact with it. Unfortunately, there's no events like visual completion in the browser. The browser doesn't provide any of that kind of stuff. There's simple things like the first paint time, but that could be just a blank screen. And so really what matters at the end of the day is the user experience, when they feel like they can interact with it, when they're happy. And so a lot of this stuff is just to get the metrics that we're measuring for single-page apps closer to what we would want the user to care about. Is that okay? Any other questions? Alrighty, I'll be around if you guys have anything later. Thank you.